Hello everyone, I'm Sun Haodai. I'm a proxy for this paper, which titled Invisible Relevance Bias. Text-to-image retrieval models prefer AI-generated images. This paper is a collaboration between Chinese Academy of Science and the Renmin University of China. I'm going to introduce this work from the following 5 aspects. Let's move on to the first, background. Information retrieval systems have become the keystone in overcoming information overload nowadays. The core function of an information retrieval system is to efficiently retrieve relevant documents from the target corpus in response to users' queries. Recently, the capabilities of generative models have seen remarkable progress, resulting in a surge of AI-generated content across the Internet. For instance, the left figure shows that as the influx of AI-generated content on the mainstream websites, the AI-generated misinformation is growing at an ever faster rate. And the left figure shows that the AIGC has been applied in various fields, such as industry, education, media, and et al. Previous studies find that the proliferation of AIGC has also revolutionized the paradigm of information retrieval systems. Traditionally, the corpus of AI systems is created by humans. However, the advent of AIGC results in a significant shift in this namespace. The content pool for AI systems now increasingly encompass a mix of both human-generated content and AIGC content. So, this paper aims to explore what is the impact of the proliferation of AI-generated image on the text-to-image retrieval systems. To approach the fundamental research questions, we first construct the benchmark for evaluation text-to-image retrieval models in the AIGC area. The corpus in the benchmark should meet 3 critical requirements. First, from the perspective of fair assessment, a reasonable scenario for accessing the potential bias requires that the generated images and the real images must have sufficiently similar visual semantics. This can avoid increasing or decreasing some semantic associations between the generated images and the queries caused by image generation. That is, the AI models preferring or rejecting an AI-generated image that is more or less semantically relevant to the query than the real image cannot prove the existence or non-existence of the bias. Secondly, the image generation pipeline should be in line with most common scenario of content generation that receives a description as prompt and generates the text or images, so that the obtained bias assessment results can be more consistent with the actual scene. Thirdly, the number of generated images and the real images should be equal to achieve fair comparison. After construct this benchmark, we generate an AI-generated image for each real image. Specifically, for a real image, we use stable diffusion to perform multiple times generation with different random seeds and get multiple generated images. Then we use open clip to select the generated image with the most similar visual semantics to the real image. After the benchmark construction, we assess the quality of the benchmark. Firstly, we apply text-to-image retrieval models on the original corpus that only has real images, and the new corpus that only has AI-generated image respectively. We evaluate the retrieval performance of retrieval models on these 2 corpus and find that performance between them is not significantly different. This shows that in our benchmark, AI-generated images have sufficiently similar visual semantics to the real images. Besides, we also conduct the human evaluation. Specifically, we invite 5 human annotators with master's degrees to participate in this human evaluation. The human annotators are shown with a triplet consisting of a query, a real image, and the corresponding AI-generated image. We then ask them to select which image, real or AI-generated, has more relevant semantics to the caption. The human evaluation shows that in our benchmark, AI-generated images do not have more relevant visual semantics than real images. With the constructed environment, we further explore the bias assessment on our benchmark. We refer to the metrics in previous studies to measure the ranking difference between real and AI-generated images of text-to-image retrievers. This matrix is shown as the formula. If the real delta is positive, it means that retrieval models rank real images higher. And if real delta is negative, it indicates that AI-generated images are ranked higher. The greater the absolute value of the relative delta, the greater the ranking performance difference between the real and the AI-generated images. Experiments on our benchmark shows that text-to-image retrieval models across different architectures and training data prefer to rank AI-generated images higher than real images. We named this bias as invisible relevance bias. Then we mixed the AI-generated images into the training data of retriever. Our further experiments show that training on the datasets mixed with AI-generated images exacerbate this bias. And the greater the proportion of AI-generated images in the training set, the greater the bias. Our findings reveals a vicious cycle. Firstly, the retriever ranks the AI-generated images higher, making them easier to be obtained by users and data selection softwares, as shown in this figure. And then secondly, retrieval models trained on datasets mixed with AI-generated images show more serious invisible relevance bias. Thirdly, the generative models trained on the AI-generated images shows the model collapse. Then the retrievals with more serious bias are applied. During the retrieval loop and the provider loop, the source bias and the model collapse will become more and more serious. To mitigate the bias that text-to-image retrieval models prefer AI-generated images, we propose a debiasing method. In our debiasing training method, we measure the text-to-image relevance score and we measure the text real image relevance score and the text-generated image relevance score estimated by the retrieval models in training, and use the difference between them as a ranking bias. Then we control the tolerance of the retrieval model to generated images based on the Bernoulli sampling. The final loss function consists of the contrastive loss for retrieval and the debiasing loss based on the Bernoulli sampling. We then conduct experiments to evaluate our debiasing method. The result shows that as the sampling probability increases, the retrieval model increasingly rejects the generated images. When the sampling probability is 50%, the retrieval model treats the generated real and image equally. After uncovering the bias in text-to-image retrievers, we will delve deeper into why retrieval models exhibit this bias. We conduct the comparative analysis of debiased retriever and original retriever to explore the possible causes of this bias. Specifically, vector T is the representation of full text from text encoder. Vector R is the representation for image from the original image encoder. Vector RD is the representation for image from the debiased image encoder. The relevance score is estimated by original retriever, and the debiased retriever is a dot product between them, as showing these two formulas. The adjustment of relevance score between the text and AI-generated image in the debiased retriever is essentially changing the values of each element in vector R. So we can get the transformation vector P performed by the debiased retriever. We visualize the result in the left figure. We find that the debiased retriever has a transformation vector P to the image representation. The transformation vector P has a higher degree of consistency in semantics across different images. Then the reverse process of the transformation can be seen as the cause of the bias. That is, the generated image causes the retriever to introduce additional encoding information to represent it. Then the additional encoded information can amplify similar parts in the text-to-image matching process, resulting a higher similarity score and exciting the bias. Here is the two related papers about this bias. The first paper first explored the source bias in text retrieval, which has been accepted by KDD 2024. This paper further explores the source bias in the text-to-image retrieval. For more details, please see these two papers from the QR code or the archive link. That's all of the presentation for this paper. Thank you. If you have any questions, please contact the first author of this paper via this email. Thank you.